Alright, let us take a look at the definitions of sample space, random variable, and probability distribution. So we're going to have to go through a lot of definitions. And let's consider an experiment. An experiment could be any experiment. We have a coin toss, for example. The potential outcomes are head or tail. Or we could measure the heights of all the students in grade 4. In this case, the possible outcomes can be any real number, let's say between 100 and 200 centimeters. Okay? But it's typically a continuous option here. Whereas this is a discrete option, head or tail. What is the sample space? Well, the sample space is the list of all potential outcomes of an experiment. Yeah? So in the coin toss case, it's head or tail. Height measurements of students, it's a number of centimeters. Now, what's a random variable? Well, a random variable is a function that maps the sample space to R, all the real numbers. So this random variable here could be a height of all the students in grade 4, and basically all these student heights will be mapped to R. This could be Bill, and Bill is 165 centimeters. Yeah, so random variable is a function mapping the sample space to a real number. What is the probability distribution? Well, the probability distribution, and let's call this X. X is your random variable. And here we have the chance that big X is basically how we symbolize the random variable, where X is actually the real value. Yeah? So what is the probability distribution? Basically, it's a mathematical function that gives you the probability of occurrence of all the possible outcomes of your experiment. Yeah? So it gives you the probability of occurrence of all the possible outcomes of your experiment. What are the possible outcomes of the experiment here? Well, there is head and there is tail. Yeah? The probability of occurrence, well, head occurs twice. Yeah? And tail also occurs twice. So in this case, the chance that the random variable is heads equals 50% in our case. Yeah. Now, also a characteristic that you need to know is that the sum of X equals to X must be 1. Yeah? Of course, these are all the possible outcomes. So if we calculate the chance that X is head and we add up the chance that X is tail, we have covered 100%. Yeah? So the probability of the sum of these p's equals 1. Now the probability distribution can be discrete, or can be continuous. Yeah, in this case it was discrete, and then we call this the PMF. PMF is probability mass function. Okay, we'll get to the continuous later. I don't want to confuse you too much.